Hello everyone, this is Rajit, students in Electronics and Communication, VVIT number. Today I am going to discuss about a concept in probability theory called stationary and ergodic processes. Let's get started. Okay, let's discuss about what is a stationary process. A random process is said to be stationary process if all the statistical parameters like mean, variance, autocorrelation, does not change with time or shift in time. There are different types of stationary processes depending on the density functions and its order. There are first order density process, first order stationary process and second order stationary process. If the probability density function of a random process does not change with respect to time, then it is called as first order stationary process. Similarly, if the probability second order probability density function of a random process does not change with respect to time or shift in time, then it is called as second order stationary process. Okay, let's see what is Weierstrass stationary process. Weierstrass stationary process, it is also called as Weierstrass stationary process or second order stationary process. All the second order stationary process are Weierstrass stationary process, but the converse is not true. Okay, condition for a random process to be a Weierstrass stationary process is first, the mean of this random process is constant. That is, expectation of a random process which is equal to x bar equal to constant. Okay, and the another condition, the autocorrelation function of a random process, it depends on difference in time, does not depend on absolute time. Here we can see this. Expectation of x of t into x of t plus tau equal to rxx of tau. That means the autocorrelation function of this random process which depends on the difference in time which is represented in tau. Okay, let's see next. Joint Weissen's process. In this, we are considered two random processes x of t and y of t. Okay, two random processes x of t and y of t are said to be joint Weissen's stationary process if it satisfies the condition regarding with their individual properties and mutual relationship. First, individual statistical requirements. Each process must be independently satisfy the Weissen's stationary conditions. First of all, process of random process x of t has constant mean and does not change with absolute time. That is, Rxx of tau does not depend on absolute time. And similarly, the random process y of t mean is constant and autocorrelation function does not change with respect to absolute time. And coming to the joint stationary condition, the cross correlation function between two random processes must be depend on time lag. That means time difference. Rxx of Rxy, which is cross correlation T depends on T1 and T2. That is, expectation of x of T1 into y of T2 equal to Rxy of T2 minus T1, which is depends on time difference T2 minus T1, and it is represented as Rxy of tau. This ensures the statistical relation between process in time invariant. Okay, if it satisfies all the conditions, individual stationary requirements and joint stationary conditions, then the random process is said to be joint Weissen's stationary process. And next we discuss about what is ergodic theorem and ergodic process. Ergodic theorem. Ergodic theorem states that for a random process, all the ensemble averages is equal to the time averages. That means statistical parameters like mean, variance, autocorrelation, and cross correlation in the ensemble is equal to the time averages time function. Okay, here we can see for an ergodic random process, the time average computed from a single sample function is equal to the corresponding ensemble averages. Here we can see time average equal to ensemble averages. And next, definition of ergodic process. The random process which satisfies the condition ergodic theorem, then the random process is said to be ergodic process. Such processes. Okay, let us see the formulas. First, mean ergodicity. Time average of mean is equal to ensemble average. X equal to limit t tends to infinity 1 by t into integral 0 to t x of t dt is equal to expectation of x of t is equal to x bar. For autocorrelation ergodicity, time average autocorrelation is equal to ensemble average. Rx of tau equal to limit t tends to infinity 1 by t integral 0 to t x of t into x of t plus tau dt. Okay, specific types of ergodicity. Mean ergodic process. A random process is said to be mean ergodic process if the time average of the sample function is equal to the statistical mean of the process. This is the most commonly encountered from the ergodic in practice. Mathematically, a process x of t is mean ergodic is represented as E of x of t is equal to x bar, which is equal to limit t tends to infinity 1 by t integral 0 to t x of t dt, which is equal to small x bar. This equality must hold with probability 1. The notation E of x of t represents the ensemble average, which is nothing but expectation, and the notation limit t tends to infinity 1 by t integral 0 to 1 x of t dt equal to represented as x bar, which represents the time average of a specific random process. Okay. Specific conditions for this mean ergodicity are: first, the stationary process of mean is Weisstein stationary process. Similarly, the variance of the time average mean approaches to zero at a sampling interval approximately infinity. And similarly, uh, art, a random process is said to be ergodic in autocorrelation when the time average time autocorrelation is equal to ensemble autocorrelation, which implies Rxx of tau equal to limit t tends to infinity 1 by tau integral 0 to t x of t into y of t plus tau dt. Okay, let us see the summary of the concept. First, Weisstein stationary process. Okay, this is also called as Weisstein stationary process. Conditions for a random process. For Weisstein stationary process is, first of all, mean remains constant, and the autocorrelation function does not depend on absolute time, it depends on time difference. Six-time stationary process. All the Weisstein stationary processes are said to be six-time stationary processes. Okay, a random process is said to be a six-time stationary process when the entire density function does not change with respect to time or shifting time. It is also called nth order stationary process. Ergodic theorem. Ergodic theorem states that all the time averages is equal to ensemble averages. Mean ergodic. If the time average is equal to statistical mean or ensemble mean, then it is called as ergodic mean process or mean ergodic process. Okay. Jointly ergodic means by considering two random processes, we can say that joint ergodic, jointly weight sensors. Here, similar to that, we are considering two random processes x of t and y of t. By satisfying their individual conditions and jointly conditions, we can say that the random processes x of t and y of t are jointly Weisstein stationary processes. Okay, let's see what conditions for jointly Weisstein stationary process. X of t mean and e of x of t, that is mean of a random process is constant of x. And similarly, mean of the random process y of t is also constant that are individual. And for joint conditions, autocorrelation function and cross-correlation function does not depend on absolute time. Here we can see the relationship between Shifton stationary process and Western stationary process. Okay, for Gaussian random processes, Western stationary process is equal to station, Shifton stationary process. Practical consideration. In engineering application, processes are assumed to be both stationary process, estimation of ensemble statistics from single relationship, simplified mathematical analysis, practical measurement and validation of theoretical models. Okay, application and practical significance of these stationary processes and ergodic processes. First, these are most widely used in signal processing and communication sets. In digital electronics and signal processing, stationary and ergodic assumptions enable for design of optical fibers, optimal filters for noise reduction, characterization of channel properties from signal measurements, power spectral density estimation using finite length records, detection and estimation algorithm based on temporal characteristics. Okay, the ergodic hypothesis allows engineers to design systems based on measurements from single long observation rather than requiring multiple independent experiments. Okay, in this mechanical and structural engineering, financial time analysis, and environmental climatic sciences, this ergodic process and stationary process are used. Conclusion and takeaways. Understanding stationary and random processes. Okay, in this we discussed about what is a stationary process, types in stationary process, that is first order stationary process, second order stationary process, sixth and Weissen's stationary process, and ergodic theorem and ergodic process. Types in ergodic process: mean ergodic, autocorrelation ergodic, and cross correlation ergodic. Okay, thank you.